One, I am Satyapriya from Physics Department. Now we are going to discuss about the topic carbon dioxide laser. In this case, the type of carbon dioxide is molecular gas laser, and an active medium is nothing but the mixture of CO2, N2, helium and H2O vapor, and then active center is nothing but CO2, and then pumping method, electric discharge method, and then optical resonator is gold mirror or silicon mirror or coated with aluminum, and then power output is 10 kilowatt, and the nature of output is continuous or pulse, and then wavelength of emitted radiation is 9.6 micrometer or 10.6 micrometer. And then principle of this experiment is nothing but the transition between these vibrational and rotational energy levels lead to the construction of molecular gas laser. Here nitrogen atoms are initially raised to excited state. The nitrogen atom delivers the energy to CO2 atom, which has closed energy level to it. Then the transition takes place between the vibrational energy levels of CO2 atom, and hence laser beam is emitted. These are the principle of CO2 laser. And then fundamental modes of vibration of CO2 molecules is there is 3 modes of vibration. First one is symmetric, next one is asymmetric stretching, and then third one is bending mode. And the next one is what is symmetric stretching mode. The figure shown in symmetric structure, and then the carbon atom is fixed in the position, carbon atom is stationary, and then 2 carbon atoms are simultaneously along the molecular axis. For example, carbon atom is fixed in the position, and each oxygen atom can vibrate in opposite direction in symmetrical to the carbon atom with each other along the straight line, and known as symmetric mode and vibration. Next one is bending mode. The oxygen atom and carbon atoms may vibrate at right angles to the line passing through the center of the gravity. This is known as bending mode, and the corresponding frequency is bending frequency. Next one is asymmetric stretching, and in asymmetric mode of operation, the 2 oxygen atom may vibrate about the central carbon atom asymmetrically. At the same time, the carbon atom also vibrate from this mean position. The corresponding frequency is called as asymmetric stretching. And the next one is construction. Along the CO2, the nitrogen and helium gas in the apparatus, the partial pressure of CO2, N2 and helium around 0.3 and then 1:2 and then 7 respectively. The discharge tube has 2.5 centimeter in diameter and then 90 centimeter in length, and this discharge is produced in DC excitation. And then sodium chloride bravester windows are used to the ends. There are 2 concave silicon mirror coated with aluminum are provided of which is completely reflected, and other partially reflecting material they from the optical resonator. And then optical resonator, the power output can be increased by the increasing the diameter of the tube. And the next one is working. The CO2 laser is generally used to additional gases N2 and helium. Nitrogen is helped to increase the population of atoms in the upper level of CO2, and then helium is helps to cool down the discharge tube and also depopulated the atoms in lower level of CO2. When the electrical discharge is passed through the gas, the electron collided with nitrogen molecules and are raised to their excited state. That is, N2 is the nitrogen molecule in the ground state, and then E is nothing but electron with kinetic energy, and then N2 star is nothing but nitrogen molecule in the excited state. The excited N2 atom undergoes a collision of the second type and makes the CO2 molecules or excited state. The frequency of the CO2 laser can be pictured in an energy level diagram is shown in figure.